why, so here's a question, why QR factorization algorithm is the way it is actually. Why? So what is the justification for this algorithm actually? So let's get to this. Now I know about my matrix A, that it's A1, A2, up to AN, okay? And my matrix Q is the column vectors Q1, Q2, and up to Qn. And my matrix R is really this upper triangular matrix actually, okay? Upper triangular matrix in which you have these entries Rij's actually, okay? So Rij's, or maybe I should write it, say explicitly, R11, R12, R1n, 0, R21, and up to R2n, and 0, 0, so on and so forth, and R and n. So these are the three matrices that you have actually. These are numbers, while A1, A2, AN, and Q1, Q2, Qn are the column vectors actually. Okay. The key thing is to find the values of the vectors Q and the values of R using the A vector. Okay. Now, if my A is equal to QR, okay, then by using what do you call the algorithm, or by multiplying the matrix Q with R, what you're going to get actually. So you're going to take, for example, this vector or this set of vectors and multiply with, say, for example, first column, take this, multiply with second column, take this and multiply with third column actually. So when you're going to take this and multiply with the first column, this should be equal to the A1 actually, because these two matrices are equal. These two matrices are equal actually. So I would say that my A1 is equal to taking this column vector, but in row vector, but in this row vector, each entry is a column vector. This is what that you have to keep. But let's keep it as, for example, let's treat it as, for example, a row vector. So take this row and multiply with the first column. So your A1 is going to be R11 multiplied by the vector Q1. What is going to be A2? So the A2 is going to be, take this vector and multiply with the second column. So R12 Q1 plus R22 Q2. And A3, for example, is going to be R13 Q1 plus R13 R13 Q1 R23 Q2 plus R33 Q3 actually, and so on and so forth. This is what it is going to be. Finally, AN is going to be R1n Q1 plus R12n Q2 and so on and so forth, Rnn and Qn. Okay, Rn and Qn. So this is what that you get as an outcome. Now let's just start with, for example, first equation. Let's give them equation number 1, equation number 2, and equation number 3. I'll just talk about, for example, first three equations, and then the rest would be really on the same line side. I would like to, get formulas for R11 and Q1 as mentioned previously. So let's start with, say, for example, equation number 1. So A1 equal to R11 Q1. Okay. So, And R11 is a scalar, Q1 is a vector, and A1 is a vector as well. So the Q1 can be written as A11 divided by R11 actually. Okay, this is what that it is going to be. Now here is the interesting thing. I know about the matrix Q that it's an orthogonal matrix, it's a unitary matrix actually. And we proved yesterday a result that if you have a unitary matrix, its columns would constitute an orthonormal system. So they will be the orthonormal vectors actually. So in other words, the Qi dot Qj is going to be delta Ij. In other words, the Q1 dot Q1 is going to be the vector R1 actually. Q1 dot Q1 is going to be 1 actually. Okay? Our Q's are the vectors. If you compute their magnitude being orthonormal is equal to 1. So, if in this vector I take a magnitude Q1 on both sides, okay, this is going to be equal to the magnitude of A1. R1 being number is going to be equal to R11. Okay, so shall I write it here? So take the magnitude of Q1 onto both sides. So it's going to be equal to magnitude of A2 divided by R11 actually. Okay. So R11, because R1 is a number. R1 is a number. So it should be really the absolute of R1, 1, but you know these R's are actually positive numbers actually, so it would be equal to, I mean you can keep it R11 as well. Now I know about the vector Q1 that it's an orthonormal vector, so its magnitude must be 1. And if this is the case, from this equation I can deduce that the magnitude of my the R11 is really equal to the magnitude of A1. Okay, this is what that you also get actually. So this means from this I can deduce that Q1 is really equal to, what do you call, the vector A1 divided by the magnitude of A1. This is what is going to be really your value of Q. Okay. Here you also got an interesting thing that R1 is really the magnitude of A1 actually. But you can also get your respective result actually as well from here, that you know in my matrix R1 was A1 dot Q1. Okay, A1 dot Q1. I can also deduce it actually, it's not difficult. How can I deduce it? That if you take for example this vector and say multiply both sides by say vector Q1. So A1 dot Q1 is going to be R11, okay, which is Q1 dot Q1. And Q1 dot Q1 is 1 because the magnitude of this is equal to 1 because the Q1 is an orthonormal vector. So the A1 dot Q1 is going to be really R11 actually. Okay, so you got your, so my R11 is A1 dot Q1 and my Q1 is A1 divided by the magnitude of A1 as mentioned in what do you call as mentioned in the algorithm. Okay, but we also know an additional thing about R11 that it's really magnitude of A1. Okay, so you got the first expression right. Now let's come to the, for example, second equation. Okay, let's come to the second equation. So now take 2. So I want my Q2 and I want my Q2, so we computed Q1 and R1, now I want my Q2 and this column actually, so R12 and R21. R12 and R12 and R22 actually, this is not going to be R21 but it's going to be R2. Okay, R22. So take the equation 2 actually. So take A2, so you got A2 is R12 Q1 plus R22 Q2. So what should I do? Now, what do I know about the Q1 and Q2s? One thing that I know about Q1 and Q2s, that Q1 dot Q1 is 1, Q2 dot Q2 is 1, and Q1 dot Q2 is 0. This is what that I know about the relationship between the vectors Q1 and Q2. So if I take this, for example, equation and multiply, take the dot product of both sides by Q1 actually. So if you're going to do this, you're going to get A2 dot Q1, okay, A2 dot Q1. So this is going to be R12, and Q1 dot Q1 is 1 plus Q2 dot Q1 is 0. So what do you get is that R12 is really A2 dot Q1. So you got another entry of this matrix. What you can do next is that take the same equation and multiply with, say, for example, Q2. So if you're going to multiply this with Q2, this is going to be A2 dot Q2 plus 0, because Q1 dot Q2 is 0, and you're going to get R2, 2, and Q2 dot Q2 is 1, so it's going to be R2. So what do you deduce from here? Okay, so we deduce from here is that my R22 is really A2 dot Q2. So this is what I got, the second entry of my second column of my R vector actually. Okay. Now I want to deduce a formula for Q2. So take the same equation and from this compute the value of Q2. Okay, so compute the value of Q2. So what would be the value of Q2 if you compute it? What would be the value of Q2 if you compute it? So you're going to compute it, you're going to get that this is really equal to A12, a vector A2 minus R12 Q1, okay, and everything divided by R22, and this is equal to Q2. Okay, this is what is your vector Q2. I can substitute, for example, the value of R12, that this is equal to what? A2 dot Q1. So this is A2 dot Q1, and this is equal to Q2. Now I know about Q2 that it's a unit vector, so it has a unit length. So if I take the magnitude of Q2, okay, on both sides, so I'm going to get what you call the magnitude of A2 minus A2 dot Q1 times Q1 and everything divided by R, and this is equal to 1. So hence you get another expression for computing R2, okay. So it's going to be A2 minus A2 dot Q1 magnitude of it. So took this R2 and thrown it on the other side, so it will be multiplied by 1 and you get R22. Hence you can say that my vector Q2 is really equal to A2 minus A2 dot Q1, okay, Q1, and divided by the magnitude of the same vector, because R22 is equal to this magnitude. So you got the formula for the vector Q2. Okay. You can carry on doing this. So I can for example take this third equation. Okay. Probably I'll end it here so that if you can make sense of it. So take this equation R3, which is really R31, Q1 plus R32, Q2 plus R33, and Q3. This is what it is going to be, I hope. So the matrix is R31, R32, R33. Yes. Okay. Now, how can I compute my R31s and R32 and R33? The same trick that you applied. Multiply the entire equation by Q1, all these terms will go away, and so if you take the dot product of A3 with Q1, okay, so this will become R31, Q1 dot Q1 is going to be 1, and these two going to be 0, actually, plus 0. Okay? So your R31 is really this. So if you take your dot product of A3 with, say, Q2, Q2, okay, then A3 with Q2, then you're going to get what? So you're going to get, this will go away, this would be equal to 1, and you're going to get R32. So this is the expression for R32. And similarly, you can get an expression for R33. By the way, you have to keep one thing in head, that I can compute. So keeping in view the matrix Q and R, the previous entries of Q and R and the vector A, I can compute this. But for computing R3, I can't, if I take the dot product as going to be A3 dot Q3, I can't directly compute it. I can compute these expressions because I know A3, Q1, A3, Q2, and so on and so forth, but I can't compute this because I don't know Q3. So the question is how to find Q3. So in order to find the Q3, we're going to do the same trick. So throw everything on other side, okay, except Q3. So the Q3 is going to be really A3 minus R31, which is A3 dot Q1 times Q1, minus R32, which is A3 dot Q2, and everything divided by what do you call R3. This is what it is going to be. And now, I can't compute my R33 from here because I don't know the Q3. But I know one thing about Q3, that it has a magnitude 1 actually. So if I compute the magnitude of this, the norm of this will be equal to 1. And the norm of this. So R33 is like a scalar, I can send it on the other side. So the R33 is going to be really the magnitude of this A3 minus A3 dot Q1, Q1 minus A3 dot Q2, and Q2 magnitude. Okay? So you have this. And once you have this, so your Q3 is going to be what? This vector divided by the magnitude of it, because it is equal to R33. So it's going to be the A3, vector A3 minus A3 dot Q1, Q1 minus A3 dot Q2, and Q2 divided by the magnitude of this. Okay? Magnitude of this. The same numerator actually. So first I will do what? And by the way, you can see that in order to compute Q3, you have all this information. You know the A3 from your matrix, you know the Q1 and Q2, you have computed it. So you can compute Q3. And once you have Q3, you can compute R33. So you can see that you are getting the same algorithm as we proposed actually. Okay? And it's not difficult to deduce actually that why this algorithm works. So we had kind of justification for our equation, our algorithm. So let me now write the algorithm. I'll just write the algorithm. I'll not justify. or do an example of it. Okay, I'll not do it. I'll just write what you call the algorithm, the QR algorithm, QR factorization algorithm, for the case when F is the set of complex number. The entries of the matrix A are from the set of complex number. It's really analog to this actually. The only difference is going to be that the dot product there are going to be a bit different actually. Okay, so it's going to imply what do you call, involve conjugate transposers actually. Okay, so here is the direct algorithm. So if I have a matrix A and you want to say factorize it in the terms of the Q, okay, and Q is the column Q1, Q2, Q3, R is the matrix as I mentioned, and A is the matrix as I said, then what you can do is this. So I can compute my Qj. So say if you want to compute your Qj, you need to compute the vector Vj divided by Rjj. Okay, Rjj. I must mention, for example, directly. So here is the algorithm. So if you want to compute the matrix Rij, okay, the entries Rij. So here you have A3 dot Q1. So what would be the inner product when you have, for example, when you are dealing with the complex numbers actually? Okay, so if you have x, y, I know the inner product on Rn is simply taking the dot product of it. But what would be the inner product on what do you call Cn actually? So it's going to be y star dot y star multiplied by x. Okay, so this is what it is going to be. So same is the case here, that Rij is really going to be take your Qj, its conjugate transpose, and multiply it with Aj. Okay, take your Qj and multiply it with Aj, so which is equivalent to having the dot product actually. And your vector say